What is the domain of F? And F is this graph here. So we want to find the domain from the graph. And what I like to do is use a ruler or a pencil and hold that ruler vertically. The reason why I hold it vertically is because as we hold it vertically, it's running across your X scale. You can see it's running across the X scale, and if I go from smallest to largest, this will tell me my interval notation. Now, as I move this ruler from left to right, what I want to do is figure out when is the first time that ruler hits the graph. And that's going to happen at this point down here. So what is that X value? That's an X value of -9. So my domain will start at -9. But I also notice that that dot is not a filled in dot, it's an open dot, which means that that -9 is not part of the domain. So I'll use a parenthesis on it. So that's the first time my ruler hits the graph. And then as I continue to move from left to right, my ruler will keep hitting the graph. It continues to hit the graph. So all of these values are part of my domain. But then we get down here where I stop hitting the graph. And this is where my domain will stop. So it's going to stop at an X value of 8. And we can see that this X value, this point, has a filled in dot, so that is part of the domain. So my domain for this function is -9 to 8, not including -9, but including 8. The next part says, what is the range of F? Once again, I'm going to use my ruler or pencil, but this time I'm going to hold it horizontally because we're looking at the range, and the range are the Y values. So if we hold our ruler or pencil horizontally, it will be moving across the Y value or the Y scale. So I'm going to go from bottom to top because interval notation should be written smallest to largest. And the first time I hit the graph will be at this point here, which has a Y value of -5. So my range starts at -5, and you can see that that dot is a filled in dot. And I'll use a bracket to represent that that -5 is included in part of the range. So I'll continue to move my ruler from bottom to top. And my ruler hits the graph. It's continuing to hit the graph. It continues to hit the graph until we get to this point right here, which has a Y value of 3. So that's when my range will stop. And I also noticed that that point is a filled in dot, so that value will be included in the range. So my range starts at -5 and continues to 3 with both endpoints included. In this part, it says on what intervals is F increasing, decreasing, or constant? So the words increasing, decreasing, and constant are all referring to or describing what's happening to the Y values, and on what intervals is asking us to identify which X values are increasing, decreasing, or constant. So I'm going to start just getting a big picture idea by tracing the graph going from left to right. So as I start at the leftmost portion of this graph and I trace, The graph is increasing along this section, and then it's decreasing, and then it's increasing, and then constant, increasing, and then decreasing. So I'm going to label that. Let's label in blue the increasing. Let's label in green the decreasing. And let's label in purple the constant. So now we need to identify what the x values are for each one of these intervals. So for the increasing, which is the blue interval, this section of the graph is starting at an x value of -9 and ending at an x value of -7. And I put parentheses on here, but some definitions call for there to be brackets on this. So it all depends on the wording in your book of whether you would use parentheses or brackets. We also have a blue increasing section here, and this section starts with an x value of -3 and ends with an x value of 0. And we have one more section of increasing, which is this section here. It starts with an x value of 3 and ends with an x value of 6. So then let's write down our decreasing section. We have in green here our decreasing section. And that section will start with an x of -7 and end with an x value of -3. And this section here also is decreasing, and it starts with an x value of 6 and ends with an x value of 8. And we have one section where the graph is constant, and that starts with an x value of 0 and ends with an x value of 3. If you're using some software to enter these answers, pay attention to the writing in the blank. Sometimes they want you to use commas to separate these, but it depends on your software. So pay attention to the directions. This part says, for what values of x does f obtain a relative minimum? What are the relative minima? Select the correct answer choice below, and if necessary, fill in the answer boxes to complete your choice. Okay, so we don't have any fill in the blank, but we're going to be able to identify the relative minimum and what are those relative minimum. So a relative minimum is when the graph obtains a lowest value in a nearby area. So what we're looking for are peaks and valleys in the graph. And I can see that on this portion of the graph, I have a valley. And if I look just in this local neighborhood here, that is the lowest value in the area. So I would say that this graph has a relative minimum. It has a relative min of -5. That's the y value at that location. And that is actually for what is the minimum, and it's at the x equals -3. That's the location of the minimum. So if I look at this part in more detail, let me make sure I'm giving you the right number for each part. For the first part, it says, what values of x does f obtain the relative minimum? The value of x is -3. What are these relative minimum? That's -5. On this part, it says, for what values of x does f obtain a relative maximum? What are these relative maximum? So relative maximum is when you're obtaining a highest y value in a local area or nearby area. So what I'm looking for are peaks in the graph like this. Because if I were to zoom in on these areas that I've circled, I would have the highest y value in that nearby area. So we're going to say that this has two relative maximums, and we want to know what are the x values when they occur. So for the first one, we have at x equals -7, a relative maximum. The second one occurs at x equals 6. And what are those relative maximum? Those relative max are at x equals -7, it's 3. And at x equals 6 is 2. So this function has two relative maximums. On this part, it says, what are the real zeros of f? So the zeros of f are referring to when our f of x is equal to 0. And what x values those occur at. So when I'm looking at my graph, I'm looking for when f of x equals 0, which is when y equals 0. Essentially, this is the same thing as asking what are the x-intercepts of f. So I'm looking at my graph, and x-intercept is where the graph crosses or touches the x-axis. So we have x-intercepts at all of these locations here. And depending on how your question is worded, you want to pay attention to whether they're asking for it to be written as ordered pairs or to just separate them by commas. Most likely separate by commas. So you would write -17/2, -5, 4, 8 for your real zeros of the function. In this part, it says, what is the y-intercept? The y-intercept is where the graph crosses or touches the y-axis. So here's the y-axis, and we have this spot right here where the graph crosses the y-axis. So we would list the y-intercept as -1. On this part, it says, for what values of x is f of x less than or equal to 0? So f of x is the same thing as y. So this is saying for what values of x is y less than or equal to 0? When we look at our picture, we can identify three sections that we want to pay attention to. We have where y equals 0, y equals 0 along the x-axis. Then above the above the x-axis, that's where y is greater than 0. So everything above the x-axis is y greater than 0. And then below the x-axis, that's when y is less than 0. So we're asking when y is less than or equal to 0, so we want to include when y equals 0, which is on top of the x-axis, and when y is less than 0, that's when the graph is below the x-axis. So I'm going to highlight the sections that we're talking about. Below the x-axis are all these that I'm highlighting in yellow. And then we want to include the values that are on the x-axis, which are these points. And I need to represent these x values. So I'm going to label these as 1, 2, yeah, that 1, 2. So interval 1 would start at -9 and continue until -17/2. So that's covering that section. And I notice that on this end, there's an open circle. So I'm going to put an open circle on -9. But on the other end, it's a filled in dot, which I want to include because that's when y equals 0. So I'll put a bracket. Then on section 2 begins right here at an x value of -5 and continues all the way until this end with an x value of 4. Both of those ends are on the x-axis. That's when y equals 0, so I want to include them. I'll put brackets. And then finally, this last point out here, it's a single point. You don't use interval notation when you have a single point. So I'm just going to list that point by itself and put curly braces on it. And so all of these x values have a y that is less than or equal to 0. On this part it says, for how many values of x is f of x equal 3? F of x equals 3 is the same thing as y equals 3. So if we're counting how many x values have a y equal 3, I'm going to go to where y equals 3 right here, and I'm going to draw a horizontal line at that spot. And the graph only crosses in one place. We just have one x value that has a y value of 3. On this part, it says, what is the value of f of 2? So let's make sure we understand what this notation means. The value inside the parenthesis is telling us that x is equal to 2, and f of 2 is asking us to identify the y value. So to identify the y value, you want to go to where x is 2, which is here, and go down to the graph, and we can see that the y value there is at -1. So f of 2 equals -1.